Well, thanks everybody for joining me tonight for this training session. And we're going to be following on from what we did last week. So remember last week we did some fault finding on the twin zone system that we built up a couple of weeks ago. Well, today it's biflow, so wide plan system fault finding. So I'll get straight into it. Let me share this with you. So it's going to be based on one of our control packs that's got the LWC1 wiring center. So this is exactly the system that we built up the other day. What I'm going to be doing now is I'm going to be trying to address the most common issues that we get coming through our tech support on this sort of system. So boiler never fires is quite a common one. Obviously the complete opposite of that, which is can't stop the boiler firing, so they've lost control. Cylinder doesn't get hot, but the boiler fires. Boiler doesn't fire when the central heating cools. Radiators only heat when the cylinder is on. And the final one that we'll look at is the radiators warm up every time the hot water is on. So that's the most common that we normally see surrounding this sort of system. The thing to remember with the mid-position valve is last week I told you that essentially the valves on a twin zone system are a buffer between the rest of the system and the boiler. We can't really look at it like that with the mid-position valve because if you remember, there is a link between the output of the cylinder stat straight to the boiler. So the valve can tell us a lot about what's going on with the system, but it can't tell you everything. You do need to get in there and test. A couple of points to mention to start with. Remember with these that one port is always open. So you've got your AB port that comes up the center, and then the water is diverted left and right, depending on what you call for. So just remember that if all you do is fire up the boiler manually, you will get some flow in a particular direction. You don't need to worry about opening the valves manually because one port is always open. And another point I'll make is that the ports, as you look at the valve straight on, and you've got the W, M, and H indicator, the ports are actually diametrically opposed to that. So on the W side of the valve, the port on that side is actually for the heating, and conversely, the other side, the H side, is actually where you would pipe your hot water. So just something to be mindful of there. And like I said, really on the intro to this, is we don't need the valve to get the boiler to call for heat. So the valve doesn't actually need to physically move for us to cause the boiler to fire, because we do have that link straight from the demand on the cylinder stat. And if you remember, this is our process flow diagram. It's not actually wired like this. It goes to the wiring center, but you can see that whilst both sides of the system do point at the mid-position valve, you have got this extra link between the cylinder stat and the boiler itself. So let's get into the first one, which is boiler never fires. So if we have a look at the diagram here, terminal number 12 is where the boiler connects to. So if we get the system calling for heat on both channels, so that's how I would normally approach it, and then further down the line I can differentiate between the two if it turns out it is an issue with the controls. But get both sides calling for heat, and then I would be measuring terminal number 12 with a multimeter to see if it's live. And if it is, and the boiler's not firing, then it would indicate that there's a boiler issue. Or if that terminal isn't, if that terminal is dead, then we know we need to look upstream to see what's going on. So let's say, for instance, that terminal 12 is going live. We would expect the boiler to be running. What I would do, next step on that would be, I would take the switch live out of terminal 12 and I would just replace it into a permanent live. So all I've done there is I've moved the switch live over to a permanent live, and we're just directly firing the boiler. We've taken the controls out of the circuit. We're just now livening up the switch live. So we would expect that to fire. If it doesn't, we'd then be looking at something boiler end. But it's just quite an easy way to split the system to know really what you need to chase. So let's do it. Again, as I said with this, we don't want to be powering up the system and having wires hanging out of the wiring center. So there is live testing. You do need to get your probes in and test, But if you every time you move the wires around, just make sure that you are safely isolating. So once we've got the covers off, we can then get the system set up as we would want. So like I said, both channels set to on, so they're both calling for heat, and set your thermostats to maximum. Ideally, if you haven't got a full tank of hot water on the system, that would be good. If we start from a cold system, would be good. But just make sure that both the stats are maxed out, and we can see there's our confirmation that the boiler's not running. So in with the multimeter, get it set to AC volts, and first thing I'm going to do is, with reference to either neutral or earth, just measure terminal 12 to see what it's doing. And you can see here it's dead. So for this scenario, if it's dead on terminal 12, it's looking more like it's a control issue. So we're not going to start tearing the boiler to bits. We're now going to start looking upstream to see why terminal 12 is not dead. Because remember, if we're calling for on both channels, the valve should be overheating. The orange wire of the valve should have gone live, but we've also got the demand side of the cylinder stat should also have gone live. So there's two chances for terminal 12 to go live. The fact that it isn't, we need to look upstream at the control side. Now let's say, for instance, on this next scenario, we measure it and we find that terminal 12 is live. So that's sort of proving our control system. What we would then be looking at is what we can do to again isolate the boiler. So here I'm removing the terminal 12, the wire out of terminal 12, not putting it into a permanent live this time. I'm going to put it into a dead terminal. So again, remember, we want to be able to power these things up, but we don't want to be, we want to be powering them up without having wires hanging out of the wiring center. So put it into a dead terminal, and then once you're at that stage, you can see, is the boiler still running? And if it is, then you know that with the switch live of the boiler in a dead terminal, if the boiler is still running, somehow the switch live is being livened up. Maybe something's tracking across the PCB on the boiler. So you then know where to look. Do I take the boiler to bits, or do I look at the controls? So terminal 12 is live, and the boiler's not running. You know that it's not the control system. It's going to be more boiler. So now we can't stop the boiler firing. So again, what we look at now, again, similar sort of thing. We're going to remove the switch live, but instead of putting it into a permanent live, it goes over to terminal 5. And obviously, in a dead terminal, the boiler, if the boiler continues to run, we've got we know that it's boiler side. So again, get the system into the right condition, stop everything. This would normally expect the boiler to stop firing, but clearly there it still is. So now this is where we get in and we move it over. So like I just described, wire out. While I'm doing this, I've got the fuse out, so it's dead. As soon as it's back in the wiring center, we can then power up. We can now get in and test terminal number 12 to see what's going on there. And you can see that's at 0 volts. So we'd expect the boiler to stop firing. If not, if we were to find that we did have a voltage there, so it wasn't the boiler side, it wasn't a fault with the boiler keeping it running. If we find that terminal 12 is live when everything is set to be off, what I would then do is start picking through the links. So we know that terminal 12 is linked to 2 other things. It's linked to the orange of the mid position valve, and it's also linked to the demand side of the cylinder stat. So I would now go through and sequentially remove links and test number 12. So isolate, remove link, power back up, test, and see when 12 goes dead, and then identify which link it is that you've removed, and that will then push you to where it is. So I mean, your options are really going to be, for some reason the micro switch is stuck on in the valve, so it's the orange wire of the valve that is causing you to be powered up, or it's going to be something's gone wrong with the cylinder stat, or perhaps the programmer, where the programmer is not going into an off condition, so it's still feeding the common of the cylinder stat. So if the cylinder stat is demanding, it's always got that voltage there to be able to liven it up. So really, you're looking at 2 areas, but by doing this, you should be able to narrow it down to which side of the system it is. So the next one, cylinder doesn't get hot, but the boiler fires. So immediately I'm sort of thinking, this may not necessarily be an electrical issue. It may be that the valve is stuck for some reason. Now, in terms of the valve, it could be the body is stuck, or it could be the actuator is stuck, or it could be, I guess, that we do have some sort of electrical issue where the valve is being told to drive to a position when it shouldn't be. Because remember, to get to the cylinder for the water side of the system, the valve is in the de-energized state. So what we would do here to prove it electrically is we're going to have a look at, and we will test the wires that we know cause the valve to move. So if you remember, the white wire of the valve, which is terminal number 4 here, that drives the valve to the mid position. And then once it's in the mid position, if the grey wire is also live, that will take you over to the heating side. So let's get that set up. So we set it up. So we set for hot water, cylinder stat up to maximum. Obviously very helpful if you've not got a cylinder full of hot water, but immediately we can see here the reason why the cylinder's not getting hot is the valve is in the heating position. So now we need to understand and try and decipher why. So electrically, we'll test to see what's going on. So let's test the white. We can see it's at 0 volts. So the room stat, so from the programmer side, the hot water on, and the room stat, we're not getting any voltage from there. But remember, if that was the last call for heat, because the grey is live, which we're seeing here, so this is now the fault condition. For some reason, when we're calling for water, the grey is live. That's what's holding it in this scenario in the heating position. So now we've got to try and go through and pick out what's causing that grey to be live. And remember, the grey wire of the valve is connected to the satisfied of the cylinder stat, and also the off terminal, the hot water off terminal on the programmer, generally terminal number 1. It certainly is for our backplate. So again, sequentially you would pick through removing links and seeing when that terminal goes dead, because the problem we've got here is we are calling for water, and yet for some reason the hot water off side of the circuit of our circuit is energized. Now, if we were to see that grey was dead, which is what it should be, so if everything checked out electrically, and the white is dead, the grey is dead, we could then essentially say that all of our controls are behaving as they should. So maybe the reason we're not getting any water into the cylinder is because there's some mechanical fault with the valve. So again, what I would do here is just press in the button, remove the actuator. In doing that, you see that the actuator has run back to the water position. So the reason that the valve was in heating is not it was being driven there electrically. We must have some sort of obstruction in the valve body, or maybe the spindle on the valve body is seized, and that's what was holding it over. So good to go through the electrical checks first, because it proves your system. But obviously you could do this the other way around, where first thing is if you clock that the valve is in the heating position, just pop it off. But I have seen it a lot of times where you can't actually see the indicator on the valve body, on the valve actuator, because it's facing a wall, and that you can't really see it unless you've got a mirror. So electrical checks sort of prove it exactly, but it's certainly a good indicator to look at that on the side. So the next one we'll look at is the boiler doesn't fire when the central heating calls. So this is quite a common one, and generally speaking, it could be that it's a valve fault, but generally there is something that's not right with the wiring, that maybe the customer hasn't seen before, because you're only missing one of your offs. So if you remember, to get central heating to call on its own, you've got to drive the valve all the way over. So the white wire, remember, the way it will work is central heating on from the programmer goes to the common of the room stat. So you've got 2 switches in series, and the output from those 2 switches go to the white wire of the valve. You energize white and you drive the valve to the mid position. Now, to get it to go all the way over, you've got to have the grey energized as well. And grey is energized when you're not calling for water, So it's coming from either the hot water off from the programmer or the satisfied from the cylinder stat. So either one of those needs to be live, or both of them. Doesn't matter if both are live, but you've got to have at least one of them live, livening up that grey wire, and then with white energized and grey energized, the valve will drive all the way over. It will hit the micro switch at the end of its travel, and then the orange will go live, and you'll see that orange is connected to the switch live of the boiler. So a lot of the times you'll find this, you'll see that the valve is stuck in the mid position. It's not traveling all the way over. So there we go. These are the ones that we will check. We will check to see if the white's going live, and we'll see if the grey is live. And you can see all of these terminals here, 8 and 16, they are all linked together. So that's all of the off side. So there's plenty of opportunity for the grey to be livened up. And if it's not, that's where we would then need to start looking to see what's going on. So we'll get the system in the right condition. So central heating on the programmer, and there we go. That's the telltale. So we're not calling for water, but for some reason the valve is not moving over. Now it could be that there's an obstruction in the body, like we had on the last scenario, that's physically stopping the valve moving past the mid position. And again, you could just pop the actuator off. But now we'll do the electrical checks, and we can see that the white is good. So we are driving it to the mid position, and we'll now measure the grey. And you can see on the grey, we've only got 66 volts. So there's clearly something going on here whereby we're not getting the full mains voltage on the grey wire of the valve, I should say, and that's what's causing it to not drive over. Now that could be that the programmer is not connected for hot water off, or if you get, particularly as this is not at 0 volts, so it's not as if it's open circuit, we've got some sort of stray voltage on there. It's normally something going wrong with a cylinder stat, in my experience. So that's where I would be looking. But again, because they're all linked together, we would then sequentially go through and pull out each link to see where it's fallen down. Now, another way you can do that, if you don't want to pull the links, is you can use your instrument. So set it to continuity, and this time we'll be dead testing. So knock the power off, and then you can just go through and you can bell out, because it may be that we've got a link that's gone down. So you can go through and you can just bell out and check your continuity between all of your different links. So you can see that from the cylinder stat satisfied, we've got continuity, but we haven't got continuity from the programmer, the hot water off side of the programmer. So, and it's a lot of the time it's the one that gets forgotten, particularly if you're at sort of a new installation stage. If you forget the hot water off at the programmer, you'll essentially only ever go into heating only mode when your cylinder stat becomes satisfied. So this is why the customers don't always notice it, but it's certainly something you can be chasing your tail on if you don't clock it and you're trying to fault find on the system. So the next one, radiators only heat when the cylinder's on. So again, this is looking like exactly the same fault that we've just had, but it's just being viewed essentially from a different angle. So before, the customer might not use hot water; they might only ever use the central heating. So their complaint would be the boiler never fires because they never call for water. In this scenario here, we've got exactly the same thing. The radiators only ever heat when the cylinder is on. So in terms of the valve, we know we're getting flow into the central heating circuit, so the valve must be moving to at least the mid position. But the problem is that it only coincides with when the cylinder is on. And if you think about it, it's exactly the same as what we've just looked at. The orange before wasn't going live because the valve wasn't traveling all the way over to its heating position, the fullest extent. But because we've now got this link from the output of the cylinder stat, so here terminal 14 you can see is linked directly, or actually it's linked via 13, but ultimately it gets to 12. That's the switch live for the boiler. So the rate in this scenario, the customer will only get central heating as a function of the hot water being on. So we can set this up with, if we're calling only for central heating, remember that the valve needs time to travel over. It's only a couple of seconds, but you won't see an instant response. And you would with the hot water side, which is directly connected to boiler. So we'll give it a couple of seconds, and we see that the boiler never fires. So again, by now it's had enough time to travel, but the boiler is still not firing. You may have just seen it there that the valve had only moved to the mid position, but now by pulsing the hot water, we can see now that we do get control of the boiler. So knock the hot water on and off a couple of times, and you can see that that's reflected in the boiler side. So as you pulse hot water, that's what's controlling the boiler. All the valve is done is it's moved to the mid position. And again, highly likely that the cause of that will be that one of the greys is not connected either from the hot water off of the programmer or the cylinder satisfied. So now we're on to the last one, and this can be a bit more of a tricky one. The report you sort of get in is that the radiators get warm. First question you really got to be asking is, do they get as hot as they normally do when you call for them, or are they just getting sort of lukewarm, something like that? And generally, if they say that they're just warming, then immediately I'm thinking it looks like the valve is passing. If they say that they're getting hot as they normally would, then that rather suggests that there's a valve wide open somewhere. So we would need to electrically get in and check to see what's going on and what the valve is doing. But we can, by all means, check that number 4, the white wire of the valve. Remember, that's by energizing white. That's the only one that's going to get the valve to move off of its seat when it's in the water position. We can certainly double check to make sure that that isn't live. But moreover, what we want to be looking at now is the indicator on the head. And you can see for this fault condition, we've got the indicator is halfway between W and mid. So halfway between water and mid. That means essentially when you kick the boiler in on water, for some reason the valve is not seated, so we are getting some flow into the radiator circuit, just not the same sort of volume as we would if we're calling for it, and that's why it's reflected as the radiator's just starting to warm. They're not as hot as they would be under normal circumstances. Now it could be again that there's an obstruction in the body of the valve. Or it could even be that you've got an actuator fault, so there's something's actually gone wrong with the mechanicals in the actuator. But what I tend to find with these is that it's being pushed off of its seat by something. Now there's 2 real things that can do that. Remember, we've got the lever on the side of the head, so if when these are supplied, they're supplied in the vent and fill position, so the head can actually be locked in. So you would need to unlock it. That's one possibility, but more often than not, it's normally that you've got a pump that's nearby. Now we say that you need a meter's worth of pipe work at least between the input to the valve and the pump. And if you don't have that, you can sort of get things pushing off the seat. Also, if you don't plumb the valve body in the right way, so if you don't have the feed coming up the center and then teeing off, if you have it coming in one of the sides, that will also cause your paddle to be pushed around. But normally what you can do is if you find that your pump is closer than a meter in terms of the pipe work to the valve, you can just drop the pump speed down, and that just takes the load off of the paddle in the valve body. Now, like I said just now, if you find that by pressing the button in and you taking the actuator head off, if you find that will actually get you to drop back to the water position, then it's not. It is the valve body that's doing it. Now it could be that it's something. There is an obstruction, or it could just be that water pressure from the pump is enough to be able to overcome the spring in the actuator and get the valve not seated on the valve seat, and as such it would be passing. So final bit that we'll look at now, we've already seen that. Let me just scrub ahead to the final bit. Like I said, taking them off, it drops back. And you can see there on that one that the little lever is pushed right at the end. Last bit I'll share with you is this. This is a really useful thing to keep on you when you're doing this sort of fault finding is the expected voltages on the different wires. Now, remember, there's a lot more electronics inside a mid-position valve, because you've got to get it to hold mid-position, and you've also got to get it to delatch. So when it's over in the heating only, you need to delatch it, and this is why you'll see the voltages more or less when we do a twin zone system. It's either 0 volts or mains volts, but mains voltage 230, 240 volts, depending on what you're on. You can see here with these, when you're measuring, that you particularly when the programmer's on, cylinder set to maximum, room stat set to minimum, you're getting voltage that floats anywhere up to 50 volts on the grey and anywhere up to 24 volts on the white. And similarly, in the condition programmer on for both channels and maximum on both room stats, your grey doesn't necessarily fall to 0. The requirement is it needs to be less than 100. So again, something just to be mindful of. If you are measuring voltages on there, they don't always drop to 0 with a mid-position valve. So it's worth keeping that in mind. And if anybody of you want that document, I'll just send us a message and I'll send it over to you. So that's it. That's me really. I've covered everything I wanted to do, which is the most common issues that we see. The other thing I will share with you is, if I can have a quick look at this, the installer handbook, the one that we used to give out when we were actually doing the face-to-face training. There is now a digital version of that on our website, and it's particularly good if you can get it. If you've got a tablet, it's particularly useful for, I don't know if you can see that with the lights, but they've got we've got about 25 wiring diagrams in the back of there, and particularly with it on a tablet, you can annotate it as you go, and that's a really useful thing. So the wiring diagrams will follow the type of packs that we do, and like you saw there, from a fault finding point of view, if you can use the LWC1 wiring center, it makes your life a lot easier.